There is a missile on this planet that can hit any city on Earth in under 1 hour. A single launch from the United States could reach Moscow before anyone even has time to react. A missile fired from Russia could destroy New York before most people finish breakfast. These weapons travel faster than 20 times the speed of sound. They fly so high they leave the atmosphere and come back down with more force than anything humans have ever created. And the most terrifying truth, once one is launched, there is no way to stop it. Today, you're going to discover how these missiles work, the secret reason they were invented, and why one mistake, one wrong radar signal could end civilization in 30 minutes. An intercontinental ballistic missile, or ICBM, is the most extreme long-range weapon humanity has ever created. By definition, an ICBM is any missile capable of traveling over 5,500 kilometers, roughly the distance from New York to London, but that's the minimum. Modern ICBMs can strike targets more than 13,000 kilometers of Hawaii easily, crossing the entire planet. What makes them so terrifying isn't just the distance, it's how they travel. Unlike cruise missiles that skim low across the sky, ICBMs take a completely different path. They launch straight upward with massive rocket boosters, punching through the atmosphere and into space. After the engines burn out, the missile no longer flies, it falls. It follows a perfect arc, just like a stone thrown into the air. Except this stone is drifting through the vacuum of space at unimaginable speed. During re-entry, the warheads can slam back into the atmosphere at more than 3,200 kilometers per hour. And during mid-course flight, some ICBMs are estimated to reach 24,000 kilometers per hour, fast enough to circle the Earth in a little over an hour. Every ICBM follows 3 phases. First is the boost phase, the violent few minutes after launch when rocket engines fire and lift the missile upward. Next is the mid-course phase, the longest part of the journey. Here, the missile coasts silently through space for up to 20 minutes, carrying its warheads toward their target. Finally comes the terminal phase. The moment the warhead re-enters the atmosphere and drops at hypersonic speed toward the impact point. From launch to detonation, an intercontinental strike usually takes 30 to 40 minutes. Less time than your favorite TV episode, but enough to destroy an entire city. ICBMs can hit any point on Earth because they don't just fly, they leave the atmosphere. To reach intercontinental distances, a missile must accelerate to about 7 kilometers per second, fast enough to climb out of the thick atmosphere and enter a suborbital arc. At the top of this arc, called the apogee, an ICBM can reach nearly 4,500 kilometers above Earth. That's higher than the International Space Station. Up there, in the vacuum of space, there's no air resistance. The warheads simply coast thousands of kilometers at extreme speed. The path they follow is not random. Engineers design a minimum energy trajectory, the most efficient path for maximum range. But there's also a more dangerous option, a depressed trajectory. It flies lower, cuts travel time, and gives missile defense systems much less time to react. Modern ICBMs are guided with astonishing precision. Early missiles could only hit entire cities. Today's use inertial guidance, gyroscopes, accelerometers, and even star tracking to measure their position in space. The exact moment the engines shut off determines everything. Too much thrust, and the warhead overshoots the target. Too little, and it falls short. The result? Modern ICBMs can land within meters of their target anywhere on the planet. 3 countries dominate the world of ICBMs: the United States, Russia, and China, and each has built missiles designed for their own strategy of survival. United States, the U.S. relies on the LGM-30 Minuteman III in service since 1970. It's a solid-fuel missile stored in underground silos across Montana, North Dakota, and Wyoming. with a range of over 13,000 kilometers and up to 3 nuclear warheads. 400 of these missiles remain on alert today. The U.S. is also developing a next-generation replacement, the ground-based strategic deterrent, expected to enter service in the late 2020s with upgraded guidance and modern electronics. Russia fields the largest and most diverse ICBM arsenal on Earth. Its forces operate around 286 missiles, carrying nearly 1,000 warheads. These include the massive R-36M DOS SS-18 Satan and its successor, the RS-28 Sarmat, capable of carrying 10 heavy or 15 lighter warheads. Russia also deploys mobile ICBMs, like the RS-24 Yars, huge roadmobile launchers that can move, hide, and fire from different locations, making them extremely difficult to destroy. China has rapidly expanded its ICBM force. The DF-5 is a long-range liquid-fuel missile able to reach over 13,000 kilometers. More modern systems, like the DF-31 and DF-41, are solid fuel and roadmobile. The DF-41, with a range of around 12,000 kilometers and MIRV capability, gives China a survivable second strike force, meaning it can retaliate even if its silos were destroyed. One of the most terrifying features of modern ICBMs is MIRVs, multiple independently targetable re-entry vehicles. Instead of carrying one warhead, a single missile can carry several, each aimed at a different target. That means one launch can destroy multiple cities or military bases at the same time. The first true missile was the Minuteman III, tested in 1968 and deployed in 1970. It carried 3 smaller warheads instead of a single large one, and the Soviet Union quickly responded with missiles like the SS-18, capable of carrying up to 10 warheads. The technology is incredibly complex. Once the booster burns out, a maneuvering platform called the bus uses small thrusters to steer in space and release each warhead onto its own trajectory. Some MIRVs can strike targets over 1,500 kilometers apart, meaning a single missile could hit Washington, New York, and Chicago in one attack. MIRVs multiplied nuclear firepower. Instead of building more missiles, both the US and the Soviet Union simply put more warheads on each missile. By the mid-1970s, each side had about 2,200 warheads on ICBMs, a number that grew even higher in the 1980s. And missile defense? Almost impossible. One incoming missile becomes 3, 6, or 10 separate warheads, each of which must be intercepted individually. Modern missiles also release decoys and countermeasures, overwhelming radars and making it nearly impossible to tell real warheads from fakes. Defending against ICBMs is one of the most difficult challenges in military technology. The speeds involved, the short timelines, and the use of countermeasures make interception extremely difficult. The United States has invested more than $400 billion in ballistic missile defense over the past 70 years. Yet there remains no reliably effective system to counter a full-scale ICBM attack. The primary system designed to defend the United States homeland is the Ground-Based Midcourse Defense, or GMD, system. The GMD is designed to intercept ICBMs at a much higher altitude during the mid-course phase of their trajectory, while they are traveling through space. The system consists of ground-based interceptor missiles located at Fort Greely in Alaska and Vandenberg Space Force Base in California. Currently, there are only 44 ground-based interceptors available to counter projectiles headed toward the United States. The concept is simple. Detect a launch, calculate the trajectory, launch an interceptor, and destroy the incoming warhead by direct collision. An ICBM travels at speeds exceeding 24,000 kilometers per hour, and the GMD interceptor must collide with the ICBM. This is often described as hitting a bullet with another bullet in space. The problem is that the GMD system has a poor test record. The system designated to intercept ICBMs, known as the Ground-Based Mid-Course Defense Program, has been unsuccessful in 8 of its 19 tests. Even successful tests have been conducted under highly scripted conditions that do not reflect the chaos and unpredictability of a real attack. The system is designed to counter a limited attack from a rogue state like North Korea, not a massive barrage from Russia or China. Other missile defense systems exist, but they are designed for shorter-range threats. The VOD and Patriot systems can intercept short and medium-range ballistic missiles at lower altitudes. The Aegis system, deployed on Navy ships and at land-based sites, can intercept intermediate-range missiles and has been tested against ICBM-class targets. However, none of these systems provide comprehensive protection against a full-scale nuclear attack. According to former Assistant Secretary of Defense Philip Coyle, all missile defense systems can be overwhelmed, and by definition, it is only if the attack is limited that the defense can have a hope of not being overwhelmed. Despite being Cold War relics, ICBMs remain the backbone of nuclear deterrence for the United States, Russia, and China. They matter because they represent the ultimate guarantor of national survival. The logic is simple. If a nation attacks with nuclear weapons, it will be annihilated in return. This concept, known as mutually assured destruction, has prevented nuclear war for more than 7 decades. ICBMs are particularly important because they are survivable. Missiles stored in hardened underground silos can withstand nearby nuclear blasts. Mobile ICBMs on trucks or trains can relocate constantly, making them nearly impossible to target. Submarine-launched ballistic missiles, which function similarly to ICBMs, can hide under the ocean for months, ensuring a second strike capability. Even if all land-based forces are destroyed, only the United States, Russia, and China field land-based missiles of this range. However, other countries possess ICBMs or are developing them. The United Kingdom and France deploy submarine-launched ballistic missiles with intercontinental range. North Korea has tested ICBMs capable of reaching the United States. India has successfully tested the Agni-5 ICBM with MIRV capability. The proliferation of ICBM technology raises concerns about strategic stability and arms control. The existence of ICBMs shapes global politics. Treaties like START and New START have limited the number of deployed warheads and delivery systems, reducing the risk of an arms race spiraling out of control. However, these treaties are fragile. Russia suspended its participation in New START in 2023. China has not agreed to participate in arms control agreements. As more countries develop ICBMs and MIRV technology, the risk of miscalculation increases. The fundamental reality is that ICBMs remain the most powerful weapons ever created. A single missile can carry enough destructive force to obliterate multiple cities. The speed and range of these weapons compress decision-making, time 2 minutes. Leaders must decide whether to launch a retaliatory strike before incoming warheads destroy their own missiles. This creates a head-trigger situation where errors, misunderstandings, or technical failures could trigger catastrophic consequences. ICBMs will continue to matter as long as nuclear weapons exist. They are the ultimate insurance policy for nations that possess them and the ultimate threat to nations that do not. Whether they ever fly in anger remains the most important question of our time.